In this presentation, my colleague and I are talking about the technical and economical feasibility of piezoelectric energy harvester for highways. The business model details are categorized in the following sectors. The necessity of having clean and renewable sources of energy has been always one of the most prominent concerns of human beings, and a lot of effective technologies such as solar, wind, geothermal, and marine have been invented. One of the most innovative one is piezoelectric, and in a simple way converting kinetic energy in the form of vibration or shocks into electrical energy. However, one of the most potential places that this distributed generator can be used is highway. In order to get a better understanding that why highway can be considered as a good source, the calculation of potential energy is fulfilled. 1.54 megajoule can be achieved by the energy of each car into mechanical work. However, approximately 5% of energy consumed by car is lost due to rolling friction, and the amount would be 0.19 megajoule, which would be adequate for 13 homes 32 kilowatts, for a car which drives 20 miles per gallon, or 52 homes 128 kilowatts for an 18-wheeler. Target of this distributed generator would be the national grid or local highways construction company for lighting or other uses within the highway. As a background of this application, Priya in 2005 invented a pocket piezoelectric windmill which was attached to a rotating cam. Yoshiaso developed an energy collection device which was embedded in the pavement, and Jiang considered the piezoelectric road model as the beam model with the pavement damping in 2013. Then in 2014, Yuan uses the piezoelectric transducers in the collection of track vibration energy for railway. An Israeli company, Innovatech, announces that they can harvest 250 kilowatts of electrical energy based on 500 cars in the single lane per hour.
My name is Geoff.Baines to talk about piezoelectric technology. Piezoelectric technology is the alternative method of generating electricity through vibrations of moving vehicles on a highway. We have different materials, but the common one is the PZ crystals, which absorb the wasted mechanical energy from the moving vehicles and convert it to electrical energy. And we have the mechanism as the AC voltage is generated and the force exerted on the piezoelectric device. This generated voltage is then adjusted and converted into the DC voltage output as seen here. And we have the application of it on a highway and the piezoelectric materials as the moving vehicles over the advanced layers. So when this force exerts on this crystal, it then deforms into piezoelectricity, which then generates energy. And the few advantages of it is this is a new technology, and the implementation of it on highway is very significant for affordable, clean, and sustainable energy source, as we have constant vehicles on a highway. And we have it's a potentially great replacement of fossil fuel in the electricity generation. But we have few challenges. One, as it is a new technology, so it needs thorough awareness and also a standard specification of it, as said by Ahmad.
Hello, I'm Yan Li. I will be responsible for describing the design and calculation of the product. The piezoelectric harvester includes two elements, the mechanical part and the electrical circuitry. For the mechanical part, after comparing the two most common piezoelectric materials, PVDF with excellent mechanical properties was selected as the material of the product. Meanwhile, in order to avoid its shortcoming of the low piezoelectric coefficient, each module is composed of CC units made of PVDF film to increase power generation. The width and length of the module are both 15 cm, so that a large fraction of the surface can be pressed uniformly by the tail passing by. There are many parameters that can affect its output. Under simulated roadway conditions, the maximum output power of each module is 200 mW. The put width is about 0.17 seconds. For electrical circuitry, firstly, it needs to change the AC voltage level into DC with 4 bridge rectifiers, which are connected to each row of the piezoelectric modules to avoid voltage phase interference. Then connect a boost converter circuit to increase the rectified output. After that, in order to achieve grid connection, the electricity is converted into 50 Hz AC by an inverter. On the other hand, these electronics also cause some power losses. The output power is calculated according to the following formulas. The average power is calculated based on the maximum power, which depends on the vehicle weight and its speed. In order to analyze its practicability according to the British traffic code, we calculated the output power of mid-sized cars and trucks at 30 and 70 miles per hour respectively. For installation, considering the cost and the probability of the car through the models, it was decided to lay only locally. After making the following assumptions, the final calculation results show that the annual output energy is 533 megawatt-hour per kilometer.
Hi everyone, I'm Boyu Jin from Group 2. I'm in charge of the cost of products. As we know, the device configuration could be seen in this picture, which consists of 6 pieces of PVDF piezo films and protective wall and base, which are made of aluminum. So, we searched the information through the internet, and we found the price through the Chinese manufacturer. Each piece cost 1.07 pounds. We can calculate the volume of the aluminum protective wall base, and then the price could be set as here. The cost of cover is needed here because it is used to increase the structural strength and the easy installation for each module. The total price could be calculated below this slide. And the layouts and price are shown in this picture. The price of cable is set as 8 pounds with realistic information. Then we come to the total cost table shown here. Then we come to the installation strategy. Because the best location from one experimental could be illustrated that 0.6 meters from the edge of the road is the best location. We want to maximize the probability of cars running over it. So we decided to set 6 modules of road. Due to the width of the road in UK is 3.65 meters. The dividence between the roads is 2.27 meters. The total number of modules and the total cost could be calculated. That's all. Thank you.
I am Xie Siyuan, and my presentation concerns the financial analysis. We made a LCOE template to find the levelized cost. Here are some necessary assumptions. The initial investment cost typically includes 3 parts. The first part, manufacture. The net cost of raw materials is estimated to be 485,000 pounds. We can purchase the materials, machines, and make the products by ourselves, which can save some cost, or we can find original equipment manufacturer. This is a modern and efficient mode. For installation, different roads, cities, countries have different regulatories. Therefore, the cost of corresponding design, construction, and trail operation should be taken into consideration. Also, the direct labor cost associated with manufacturing and installation would be added into investment cost. So the initial investment cost will be 530,000 pounds. Secondly, it is operation and maintenance cost. According to the maintenance cost for the highway agencies roads of the UK government, England highway maintenance budget ranges from 4,000 to nearly 7,500 pounds per kilometer in 2019. Considering that the maintenance of PEH device only includes crack sealing and fitting, which is a small part of whole maintenance process. So the operation and maintenance cost will be 4,000 pounds. The operation and maintenance growth rate will be 1%. The annual electricity output will be 533,000. The discount rate would be set quite low, about 1%, which corresponds to a medium risk investment environment, different from other power generating systems such as nuclear, wind, solar. The operation and construction of PEH is safer and cheaper. The LCOE of this PEH device is estimated to be 0.12 pounds per kilowatt hour. According to this bar chart, we can see LCOE of some renewable energy and conventional plants in 2018. PEH highway technology still has higher LCOE. However, the growing science and technology improve the efficiency and capacity of renewable energy power plants. For example, the average LCOE of solar decreased from 0.36 in 2010 to 0.1 in 2017. So optimistically, we think the LCOE of PEH highway will also decrease in the future.
Hello everyone, I'm Nissan. Today I'm going to tell you about the marketing part of our product.
Let's first looking at the promotion way. This part is talking about the ways how we can make other people know about our product. There are two methods. The first thing is about using the social media. We need to build our own website. The second thing is that we can attend some more specific activities. For example, like the exhibitions on renewable energy or conference focused on the environment. Then, let's look at the target market part here. In this part, we are talking about the market distribution of our product. Although we are using PCT on highways, it is not necessary and possible for every highway with this technique. We need to find some trees. With these trees, the highways are suitable for this technique. And I will explain them in some example. Like the highway to the airport, the number of the cars travel through it is considerable, and it is usually more than one traffic line. So when considering the maintenance job, it will not affect the normal traffic efficiency. And then for the highways in industrial area, there are lots of manufacturing companies and factories there. And as shown before, the heavier the car is, the more energy it can be produced by this technique. In this part, we are talking about the sales and benefits. In our business model, the ideal buyer is the government, since this is an environmental friendly technique. And when the government invested, we apply it with the road agency. So when the cars traveling through it, the energy generated by PCT would be main income of our company. There are also additional services because PCT can be used as a sensor as well. Finally, let's come to the competition part. Compared with the traditional energy, the biggest advantage is that it is zero CO2 emission, and compared with the renewable energy, it has the higher efficiency and a shorter payback time.
Hello everyone, my name is Deng Zhixing. Today, I will talk about risks. We will start with SWOT analysis. SWOT analysis identify organizational strengths, weaknesses, and project opportunities and threats, which is very useful for identifying. We have four main risks. Firstly, some factors may result in more investment than expected. For example, when the weather is bad, it's more difficult for construction, which results in more installation fee. The first and second responses help us avoid the risk in advance. We secure more funds and try to reduce the cost. If the risk happens, we will take the third action to increase profit to reduce risk. Secondly, piezoelectric technology implementation may lead to traffic problem. To avoid this risk, we choose roads with more than one lane. Moreover, government should have a plan. Thirdly, some people may question that the system is based on vehicles which emit greenhouse gas. To avoid this problem, we tell others that harvesting energy from vibration is better than nothing. Moreover, the roads can be rebuilt to vibrate more to increase efficiency. The last one is the lack of research on piezoelectric technology. We need to encourage people to pay attention to this field to reduce risk. The more the studies on it, the better piezoelectric technology develops. Next part is intellectual property. I will talk about patent and industrial design. We don't infringe any patent, but we don't plan to apply for our own patent now with the completion of our product. We may apply for patent in the future. In terms of industrial design, we plan to apply for design rights in the UK. That's all. Thank you for your attention. The next part will be discussed by my colleague.
Hello everyone, here is Mingxi Zhang. I am going to talk to you about the ethic, environment, and law. Firstly, in the ethic level, piezoelectric harvester could improve people's awareness of the importance of this new power and clean technology, because currently the energy and environmental problems are very serious, and our products would solve the problems to a certain extent. Moreover, it could bring comfort to people's heart, letting people know that as long as there are cars running, there would be continuous power generation. Secondly, on the environmental side, this technology does not make noise or emit any greenhouse gases, and no additional land space is required when installing the panels. Therefore, our product is environmentally friendly, which is very important. Then let's look at some of the laws that our products need to comply with. And in this picture, here are some existing laws and regulations of piezoelectric production, such as supply chain and manufacture. They aim to minimizing health, safety, and environmental impacts of the products. Finally, I'd like to turn to the future work. There are still many aspects to be optimized and improved in our technology, such as energy storage And the most important is how to generate more electricity. As long as our product can make greater power output, we will have more profits to gain. In summary, our product and technology is still in its infancy, but it is feasible and profitable. The generation of electricity does not require any separate source of input energy, and just relies on the consumers. So in this era of serious energy problems, it will be strongly competitive in the area of new energy technology.